Hello and welcome to the video. My name is Derek Cannon, and in this video we're going to be solving a problem regarding kinematics in two dimensions. This is a pretty straightforward problem. I would say that this problem is geared for beginners in physics, but it has some significances that would be important for physics students of all levels. Um, the first thing that's significant about this problem is that um, beginners, the intuition of a beginner might tell them to take these two velocities here, add them together, and divide by 2. But though that might be intuitive, that is not, in fact, the correct way of doing it. In order to correctly solve this problem, we need one formal definition, and that is that the average speed is equal to the total distance traveled divided by the total time elapsed. So the total distance is already given to us. In the last sentence here, what is the car's average speed for the 200-kilometer trip? So it's stated here, and it's also stated in the first two sentences, 100 kilometers for the first interval, and then another 100 kilometers for the second interval. So already we know here that total distance is going to be equal to 200 kilometers. Okay, but now what is total time elapsed? So the second reason why this problem is significant is because it incorporates the multiplication of two units to achieve another unit that's desired in order to solve this problem. The unit that we're looking for is time. And here we have hours in these two velocities. For speed, we're going to want distance over time, right? And so we're working with kilometers per hour. Our final result, we are going to want also in kilometers per hour. In order to find time elapsed, you have these two segments, a velocity and a distance, and a velocity and a distance. This velocity and distance, obviously, for segment 1 or interval 1, and this velocity and distance for segment or interval 2. Okay, so how do we take these units here and acquire time from them? Essentially, what we're going to want to do is we're going to want to flip this, so instead of 100 km divided by h, we'll have h divided by 100 km, and then we're going to multiply that by the 100 km. So really, what we're going to do here is we're going to take 1 divided by velocity 1, we're going to multiply it by, why don't we do distance 1 in this case, okay, and then we're going to add this to 1 divided by v2 and multiply by d2. And just for readability, PEMDAS will give us the correct result regardless of these parentheses, but simply for readability, I'd like to put those in there. So at this point, when we take the reciprocal of this, which is equivalent to this, we'll get h over 100 km times, or excuse me, h over 50 km times 100 km, that will give us 2 hours, I believe. So let's simplify our total time elapsed. Okay, so this is going to be h divided by 50 km times 100 km plus h divided by 100 km times 100 km. Okay, now so when we multiply these two together, the km's cancel, and then we have 100 divided by 50, which will give us 2 hours. And we're going to add this 100 km divided by 100 km is 1, so we're going to be left with 1 hour. Now this will be equal to 3 hours. Cool. So now we have our total distance to plug in here, and we have our total time elapsed to plug in here. So then average speed is then equal to 200 km divided by 3 hours. So now we'll take this, we'll plug this into our calculator. I'm pretty sure that this is 66.666. It's a non-terminating decimal. But let's plug this into the calculator. Okay, and then the smallest amount of sig figs in the, or significant figures in the problem is 2. So we're going to round this to 2 significant figures. This is going to be 67 km per hour, which is what we were originally seeking. So if you were to use what your intuition was telling you from the onset, and that's taking the two velocities and adding them together, okay, and you were to divide them by 2, you're going to get 75, which is kind of close to what you're looking for, but it's not exact. In order to find average speed the correct way, we need to use the formal definition for speed. So this is our answer here. Thank you for watching. Again, my name is Derek